I think where we left off yesterday was with static variables, if I'm not mistaken. Um, so a few things there, for sure, if you were hitting a constant, you definitely want to mark it static final. We're talking about, I think, final keyword is just a few sections up. Yeah, so we'll get to those. So it's good to use the word static when you're dealing with constants because you only want one instance ideally of that constant. You don't want to have a bunch of duplicates of that constant. But using static for other things is not something you want to do, including the singleton pattern, which relies on a static. Don't do it. I'll show you a different way of setting that up with Android that uses the application class instead of actually building a singleton. Um, so that's the thing to be aware of. Static methods are great. Means that you're writing a utility method that you can use anywhere. So have those as an idea. One common thing that trips people up with static variables is assuming that if I've got a static function, I have to have static variables to go with it, right? That shouldn't be the assumption. If you have a static class and it needs to access some variables, they should probably either be local variables or there should be parameters to that function. One interesting thing that does occur in the world of Java is you can write static initialization blocks. This does also exist in C# with a little bit of syntax. But if I have a variable like this that I need to initialize, it's a constant, I may need to write more than one line to initialize it. In this case, I'm putting these two kind of curly braces that are floating inside of the class. So this is code that's going to be run the first time the class is used. Does that make sense?
Couldn't you just use constructor?
Well, no, because the constructor, remember, the constructor runs every time I create a new instance, right? So if I create 100 instances of this, how many arrays am I creating? 100. This should really be marked probably static, actually. Oh no, this is instant initialized. I'm looking at the wrong one. This is instant initialized. Yeah, this one you'd want to do in the constructor. This one more likely I'd want to do in the constructor. Sorry, I was thinking about this one. So that one you can do in the constructor. This code would actually run before the constructor. So if you had a bunch of different constructors that all need to run this code, that's why that exists, rather than duplicating your code. But this here specifically, sorry, is what I'm going to jump to, is talking about static initialization. So it's got the static keyword there and the static keyword. Won't see too much of that, but it's a handy tool to have because it does come up sometimes. Inheritance in Java. So let's say I have these two classes. I've got fruit and I've got apple. So apple is a kind of fruit. Now pay really close attention to the syntax here because the syntax has changed a little bit. So note that I have the class fruit, nothing special there, right? I'm just saying it's a fruit and it's got a flavor. Note, however, if I'm looking at the apple class, do you notice anything special, anything different about the apple class?
It's using the extends keyword instead of using the semicolon.
A colon, right? Because in C# we wrote this as apple colon fruit. Okay, so if I want to create a subclass, I need to say it extends fruit. The reason for that keyword being there is thanks to interfaces. So we do interfaces with a different keyword, which we'll get to in a minute. But we use the extends for subclasses, we use implements for interfaces. Yes.
I was just gonna ask about, so C# saw that Java had two different words for either extending a class or implementing the interface, and then they just basically said, no, we're just gonna do it with one.
Do with a colon, which actually was how C++ did it. C++ did it with colon, and then all of the things that it extends.
So then when like Sun, I don't know, microsystems, because they added the interfaces too, they thought that the colon would.
They thought this made it better, more readable, which it does add some value there, because I can tell that this is, by this being extends here, I know that this is a class that is extended, right? I can have classes that don't have, they're a subclass, right? So I could say fruit implements compare without having a parent class, right? So I might implement interfaces without implementing classes, and then it's not really clear in C# what you're implementing as an interface or as a class. Which is one of the reasons probably I think that that may be one of the reasons that Microsoft decided to start their interfaces with the letter I, because you needed to then disambiguate.
Then you can't extend into more than one superclass.
Yes, you only get one superclass. Again, that's one of those changes from C++. C++ let you extend as many superclasses as you want. You only get one with Java. One of the things that means is you have to be very careful about picking what you're going to extend, right? Because you can only extend one thing. So you have to kind of think about your hierarchy of classes, because that can sometimes bite you. It's like, well, I need to be this thing and I need to be that thing. Well, you can't. You only do one of those two things. So you oftentimes end up having to do a little finagling when you get into cases like that. Okay. So every class is also a descendant of object. So implicitly, this fruit is also a subclass of object, even though I didn't say extends object. That just happens automatically.
Kind of question of terminology. The parent object is always going to be what
the parent class.
Like the class is directly descended from.
Yes, the parent class.
So like not the one. So like in this case, Apple would be, its parent would be fruit, not object.
Yeah.
Right?
You want to think about it in terms of like a family tree. So if I have object and I have fruit.
So object is like the grand.
Yes, exactly. So if I look here, see, fruit is a parent of apple, object is the parent of fruit, but if I'm looking at this, yeah, object is the grandparent.
Yeah, and it's still inheriting from both.
Yes, it's still inheriting from both, but we would refer to this, only this one as the parent of apple. We refer to this as a grandparent or an ancestor, right? Yeah. Anything above this first parent, is considered an ancestor. So that's when we use the terminology. We mean parent, and then we talk about ancestor. So ancestor is everything, including both of those. So upcasting in Java, similar to how it works in other languages, that just happens automatically. There's no problem with upcasting. And upcasting, that's where we talk about taking the family tree, and going up, right? Because an apple is a fruit is an object, that's always safe. There's never any danger going up the tree. Does that make sense? So that can happen just automatically, where, for instance, I can say, what's going there? I can say that an apple, set that into a program. Okay. So I've got A is equal to F, right? So this is an apple. And implicitly, I'm taking this apple and turning it into a fruit. See that? I'm not writing any sort of cast. It's just being casted on. Does that make sense? It's always safe to go up because we're always saying, the whole idea of inheritance is we're saying this is a more specialized version of the other thing, right? So if I had, this is fruit is, it replaces with the word list and replace that with the word array list, I can easily take an array list and put it into a list because an array list is a list or a linked list is a list. Okay. Now, the other direction is where things are dangerous. So if I want to take my fruit and turn it back into an apple, I have to be explicit about that. I have to use what we call an explicit cast to say, yes, I'm sure this is an apple. Please convert it to an apple, right? Because not all fruits are apples, right? What might be in here? What kind of fruit might I have in here that's not an apple? Orange, right?
Nice.
So if I have an orange here, and I try to downcast this orange to an apple, I'm going to get an invalid cast exception. It's going to tell me I can't cast your apple, I can't cast this thing as an apple because it's not an apple, it's an orange. Okay, similar thing if I try to cast an apple as an orange, that doesn't work, right? So downcasting is where you might get an exception. That's why you have to be explicit about it, versus going the other direction, going up the tree is always safe.
So if I have a like instance fields in the Apple class, that when you make that explicit cast, are they just set to like default values or?
No, you can't cast. If it wasn't an apple to begin with, the question is when you said new, when you constructed it, what was it constructed as? Right? So if I said new apple, it has all the variables from apple, all the variables from fruit, and all the variables from object. I cannot turn it into an orange because it doesn't have the variables that orange does. Right? Orange has some special variables that I don't have.
So is that the same thing as using like the as keyword for C#?
No. So the explicit casting is the same. Remember in C# there's two ways to cast. You can do an explicit cast like this with the parentheses, or you can say F as apple. Okay. Do you remember what the difference between those two is?
So when the as will treat it as like a try test, right? And if it's not it, will turn into null, right?
Right. Yes. So if I do an explicit cast, if I try to cast an apple to an orange, I get an exception. If I write F as apple, I would get null. Sorry, F as orange, I would get null because they're not that. That doesn't exist. So the only thing that exists is the explicit cast version of that. You have to deal with those problems yourself. Whether that means catching the exception or that means, usually it means doing the latter here, which is you can use the instance of operator to say, is this the thing that I want, right? So rather than immediately going and assuming that everything is apples, I can say, is F an instance of apple? If so, then let's do this, right? So I can say, if it's an instance of an apple, then go do that check. Otherwise, I'm just going to do something else. Like say, hey, well, if it's not an apple, maybe it's an orange, right? Maybe I want to do something different with an orange. So that instance of operator can be very helpful when you need to check if it implements something. A lot of times things like this can be very helpful when you're dealing with, say, interfaces. Saying, does it implement this interface? But overall, we want to do as much as possible. As much as possible, we want to avoid downcasting. Okay, because downcasting has a cost. Overriding. If we create a subclass, we can change the behavior of the parent class, right? So I can create these two classes here. I have the rectangle. Rectangle has two attributes, the width and the height. They're defaulted to 10. And I can calculate the area of that rectangle. So I've got get area returns width times height. Okay, all sensical there. Now I created the subclass called triangle. I've said triangle is a subclass of rectangle. Okay, so that means it also has a width and a height, right? Because it got it from the parent class, and they're still defaulted to 10. I can call now area here, and I can say, well, I'm going to change how area is calculated. Area is width times height divided by 2, right? So if I have a triangle and I call get area, I'm going to get a different calculation than if I call it up. Right? Now this one's kind of weird because is a triangle really a rectangle? Mathematically, not really. I mean, this code does work, but if I were to have a rectangle that's actually a triangle, I think that might be very weird. So while you can do that, that's not necessarily a good way to build your hierarchy, because it betrays the meaning of is.
Maybe another dimension works.
Mm-hmm. It may be what?
Maybe in another dimension it works.
I don't know. The thing to be aware, though, notice that there's something very different that I did here that's different than C#. Even right here, I'm overriding. There's something I didn't have to do.
There's no virtual keyword and no override keyword.
Correct, right? Remember when I override methods in C#, this would have to be marked virtual, and then that would have to be marked override. Okay. By default, every single method in Java is virtual. All methods in Java, unless specified otherwise, are virtual. Okay? And what that really, in practice, means is that everything except for methods that are marked either final or static or virtual. So depending on how you define a method, if you declare it initially as final, that means it can never be overridden, so therefore it's not virtual. Or if you mark it static, well, static methods can't be overridden, so they're not virtual. Does that make sense? That does mean that there's an extra cost to that for most methods, because calling a virtual method or calling a non-virtual method does cost a little bit extra in terms of runtime, because it has to look up where's the address of that method at runtime. So that does mean your programs will run a little bit faster. We'll talk about final in a minute. That can speed things up, but that's the thing to be wary of. If you don't have to mark anything virtual to override, right? And you don't have to put the word override to say that you're overriding. So it can be very easy to accidentally override another method when you didn't need to. Yeah. That was a bit of a problem. So one of the things that we saw in Java 5 is they finally introduced something called annotations. Right? So annotations start with this @ sign, and they provide basically additional keywords that we can put in there. And in this case, we've got the override annotation. So the override annotation we put on that subclass to say, yes, I really meant to override. Okay. So as far as that goes, historically this hasn't been required. Originally was introduced, the override keyword wasn't required. You could still build your code and run it fine without that. I can't remember what state it is in right now. I know for sure if you don't include the override, you get a warning. And I can't remember if they've converted that over to an error yet. But you may see that if you override a method and you forget to put the override annotation there, you may see an error when you go to try to build it. So that's the thing to remember. Use the override annotation to say, yes, I really did mean to override that method. Okay. You can also, I don't remember. Oh, okay. What are they saying there? Because those are both static. Correct. Yeah. So static is a different story. So one of the other keywords that you have here is we can add the final keyword to any of our methods. Final says, I can't override this in any of my subclasses. So that actually is probably an underused keyword in Java, to be honest. It's one that's really worth keeping in your back pocket, and honestly, most of your methods should probably be final. Many of them should be. It's one thing that people forget about pretty frequently, to mark things final. But for two reasons. A, it does help a lot in terms of making sure things, unintended consequences, are not happening. So for instance, if I say I've got a getter that returns the width of this rectangle, I probably don't want to have any subclasses changing that to return something else, right? So my getters are probably a really good place to mark them final, just because even things like that, I probably don't want my subclasses to change. The other thing that happens once you mark it final, it actually is a little bit of a performance boost, because now it doesn't have to look where that method is. So you can use the final keyword to actually get around the performance loss of everything being virtual by default. If I want to access the base class, I can use this word super, just like I used the word super in my constructors to refer to the base class. I can use the word well, here we haven't got to that yet, but super is how I get to that parent class. So rather than writing width times height again, as we did up here, I can be a little bit simpler, reuse that code and say, well, I'm just going to take the width, in the triangle, I'm going to say get the area of the rectangle and divide it by 2, rather than writing that code twice. Okay, that can speed things up in a lot of cases, especially where you have a very complicated parent class implementation. Okay, constructors, similar thing here. So if I want to call the parent constructor, and let's say I have a constructor for the rectangle, it takes an A and a B, who's width and height, I can call that using super AB. So remember, this is to call a constructor on your own class where you're at, and super is to call a constructor on your base class. Okay. If your base class only has one constructor that takes 2 inputs, right? So like, let's say we make the rectangle, only has one constructor that has to have a width and a height, right? Well, in my subclass, I'm going to have to define my own constructor that takes at least those 2 and passes them on to the parent. Okay, you can only get a default constructor if your parent class has a default constructor. Does that make sense? Your subclass only gets a default constructor if your parent class has one. Yeah.
So if there's no constructor, is it automatically being generated?
It's automatically being generated, remember? So if I don't have a constructor here, there's a default constructor, it takes no arguments, and it would initialize things as we've seen here. So here you can see it's width 10 and height 10. When I construct a new object, that's what the dimensions are going to be. If I want to be able to change those values when I create the rectangle, I need to write my own constructor. Okay. So parent constructors, packages are kind of a big deal too. So we've seen a little bit of that already. The first line of any class you write is where you define what packages it's in. This always has to be the first line of your Java. You can't put it anywhere else. Okay. On the first line of code, you say package, my package. So that puts this file now into my package, and remember it has to be then in the folder with the same name. Similar thing, you may see package sub.mypackage, so that means it's in folder sub, and then inside there in folder my package. Okay, so that's how we declare what package your class is in. Okay. We do that to split up our code. Once we get into larger programs and we have maybe 100 plus classes, it would be a problem to put them all in the same folder. Okay. Remember how in MVC we split things up between controllers and models and views, things like that happen, and those are common ways to split things up. So you'll see that. Okay, once we've declared what package, we can also then start declaring our class. If I want to access a class from another package that's not in my own package, as long as it's in my own package, I just write the name of the class. That's fine. I don't have to write the path. But if I want to specifically get to one that's in a different path, I have one of two ways to do it. So I can refer to it as sub.mypackage.myClass. That's the fully qualified name. I can do that anywhere. Or I can say at the top of my file, say import this class. And that means I don't have to specify the fully qualified name throughout the file, right? This is like our using, similar to the using that you see in C#. But the difference with the using in C# at the top of the file was that we said basically just the namespace, right? We only said my package.sub. We didn't say every single class that we're using. Does that make sense? So here we have to specify which class we're using. Now, there is another syntax here. If I want to say grab every single class in a package and bring it in, like so, import java.util.star, that brings in everything from the Java util package. Okay? So everything in that package, I don't have to refer to by its fully qualified name anymore. This does work. You will see a lot of code out there in the wild that is written this way. This, by a lot of people, including me, is considered a code smell. Okay? Now, the reason for that is this works okay as your programs are kind of small. As your programs get bigger and bigger, this becomes more and more of a problem. Because two things. First of all, well, now I'm requiring everything in that package, right? So the compiler can't be clever about knowing what you're not using, first of all. That's kind of the minor thing. The biggest thing, though, is you're saying you want everything, okay? Well, what happens when Android or Java decide to remove a class from that package? Or they decide to add a class to that package? More specifically, if they ever decide to remove one, right? Well, now you don't, it's a lot harder to tell that there's a problem, right? And the other thing, the big thing that happens though is, sorry, let's say they add one, right? I have a class called myThing, and now Java decides to add a class called myThing. Okay, that was fine before they added that class, because my name was unique. But now they've added myThing, and there's two classes named myThing. Now your code doesn't do it. And it's a nightmare because you can't figure out which one, was it supposed to be the one that I created, or was it supposed to be the one that Java had? It could be a little bit hard to sort that out. So, okay. So what it results in is what we call namespace. Did I put the name in my comment here? Namespace pollution, that's the word I'm looking for. So this results in a problem in all namespace pollution. You've got all these names, in your namespace, right? So every name, every identifier that you use, whether it be a class name, a variable name, or a method name, typically needs to be unique, right? You want it to typically be as unique as you can. If I don't have it, if I have a name that I'm using for, let's say, a method and a variable, I may have to do some things to disambiguate which one I'm referring to, right? So the more things you put into your namespace, the more identifiers that are currently in use, the more likely that you're going to have a collision, right, between two things having the same name, right? So when you take in an entire package, now you just added another 100 names that you can't use, right? Because Java util is pretty big. Right, so now every single one of those names, if you have a class or a variable or a method by that same name, now you have a problem. Right, so avoid that.
Plus, it's like hard to like figure out which package it's coming from.
Right, because there are things in Java where there are two things by the same name. And I think list and timer may be some of those things. There are a few things that ironically have the same name. There's two classes or two interfaces with the same name in Java. So that can be hard. Similar thing here. So we can also bring in static methods. So let's say we have the class math. Math has got a lot of nice utility methods that we can use for calculating, like ceiling and floor and sine and cosine and exponent and etc. So those oftentimes maybe makes your code a little bit easier if you don't have to write math.ceil, math.floor, right? Some of those things, it may make it simpler to just write the method, right? So this can be helpful sometimes to kind of alleviate that. I would say the same kind of thing, especially worse on this front. Never use the star version of this because these are bringing in method names, and this is even more likely to get a collision than your class names. Especially because they start with a lowercase letter. Now remember, all of your methods and your variables start with lowercase letters. So the chance of this colliding with your variable names is pretty high, including the fact that there's one in here called max and one called min. So now you can't call any variables max or min if you do that. So if you're going to bring this in, bring them in by name. So if I want to bring in a specific function, I would say java.lang.math.floor, and that will bring in just the floor function. Or if I wanted to bring just the sine function in, I can do that again. So I can actually have more than one of these. Does that make sense? So it's better to have an import statement, an import list that's really long, and your IDE will help you with that, and because it will automatically figure out, oh, you need this class. I think the shortcut for it is alt tender once it recognizes it. So it's really easy. The IDE deals with that pretty well. So just having a long list of imports, that's a good thing. Having a short list of imports is not a good thing. By using star. Yeah.
So like in terms of what we did so far, like the packages we the folder that holds all of the Java files.
Yeah, basically. Basically.
So the source folder be that package in terms of what we did so far.
So the source folder is the root package of your application.
Right.
So it doesn't have a name. Right. All the packages underneath source haven't. All the folders underneath source are basically packages in the typical sense. So if I move that source into, if I added a folder under source called my program, right, now and put things in there, they would be in the package my program. But when they're all the way back up to the root just in source, they're not really kind of in the package. They're just kind of floating. But they're really in the root package, I think is the name of that. So looking at access levels, because we've kind of talked around this a little bit. There's one access level that we have to talk about in particular because it's different and it's important. So first of all, the public access modifier is easy, means you can get to it from everywhere. Okay? So public's wide open, anything and everything is valid. Okay? Private says the only people that can get to it is functions or methods that are in my class. If you're outside of my class, you can't get to it. Okay, once you leave the bounds of my class, that's it. Protected is going to be your subclasses with a little addendum that's easy to miss. Okay, I wish that didn't exist. This is something that's really a bang on Java, but package or subclass. So if you mark something protected, it's accessible to all of your subclasses, which is great, it's what you want, but it also becomes accessible to everything in the same package as that class. Okay, and this is actually one of the reasons why we end up creating a lot more packages in Java, because we don't want to break that package bound accidentally. So anything that's in that folder can also access that. Does that make sense? Anything in the same package can also access a protected variable.
So C# is just the subclass?
I think it's just the subclass. I'd have to go back and verify. I don't think this exception exists in C#, but I would have to go verify that. And the point is, this is very generally not desirable. There's very, very few cases where I've seen this as being a desirable result. Now, there's one here in the middle, okay? And this is what we call package access or package private. Notice that there's no access modifier here. So if I don't put an access modifier, okay, whether this be a class or a variable, a member variable, field, or a method, if I don't put an access modifier, it is package access. Never do this. You should never leave your access modifier off, ever. What that says is anybody in my same package can get to that. Which means now you have a whole lot of code that you have to potentially test. Does that make sense? Because the scope of that variable is now so big. Let's say you've got 20 classes all in that same package. All those 20 classes could potentially modify this variable. So you got a few thousand lines of code to identify.
What if you do that with methods?
What do you do with methods? Same thing. Any class in the same package can get to it.
Because I remember like C# when you like auto generate a class, it would just leave off like the public private.
Because they're a little bit different with what the default is. Their default, depending on what it is in C#, sometimes it's package, namespace, but sometimes it's also private. It's the documentation, if you read on into it, what the default is a little bit convoluted. There's a few paragraphs worth of text to the explanation. So there's a lot of special cases when it comes to that. But you should, as a general, very good rule of thumb, always put public, protected, or private. You have to have a very, 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 very good reason to do this. And if you are doing this, your package should not have very many classes on it. Because you need to verify that, okay, I've only got packages, I've only got classes in this file that it should have access, right? And more than likely, if you have something like this, it may be a class that isn't used by anybody else that's using your software, if that makes sense. It's something you're trying to find.
So is that like the same thing as internal?
Yeah, actually, if I remember right, I think that internal and package are the same thing. Yeah, I believe that you're right. Internal and package, if I remember right. So that's the one to be wary of. You'll see a lot of code examples that leave off the access modifiers, but just don't do that. Know that this is unusual. practice, it may seem like you're saving a few characters, and I have run into a lot of developers that thought, oh well, if I just leave it off, it's private. Like, no, it's not private. It's package, which is completely different from private. So that's how that looks. Package private access. So let's say we're here to kind of give that an example. So we've got this class first here called my app that is in my package, and it's got 4 different variables here of different access file modifiers. So I also got my class. My class is allowed to get to everything except my private. Does that make sense? Because it's in the same package, it can get to my package. Because it's in the same package, it can get to my protected, and public it can get because it's in public. So it is really important, because of how private and package work, to make sure that you're splitting your packages into smaller chunks, because then at least you limit how many different classes can get to those variables or methods. Top level classes, you'll just want to make sure your top level class is marked public. If you've got a class, if you've got a file named public class.java, well, you should have that be a public class. Nested classes are a really, really, really useful thing. You'll see where this is kind of having a class inside of a class. You can mark those public or private. It all depends on what you're doing. We will be using those a good amount in Android, because there are a lot of good things that they do. So one of the things that happens with private classes, if I have a private nested class, it can get to all of the private variables in my class, not just the public ones. So I can get to all of those variables, but it's also hidden from the outside world. So for things like event listeners, we'll use this, or array adapters, which we use to display lists of items. Both of those two things we'll use nested classes for. They're very useful in that front, because they automatically get access to the private variables without forcing you to leak all those member variables out via getters or making them public. So it's really helpful for small classes that kind of are part of the larger class. Does that make sense? You want to kind of keep them, you want them to have access to your private variables, but you don't want to expose them out to the rest of the world. They also implicitly, every nested class automatically gets a reference to the class that's in it, right? So if I say nested class, if I say private nested class, that actually has a reference to the my class object that that created it automatically. So it kind of belongs to the parent class. Any instance you make belongs to the parent class. Okay. So we may dive into that more when we get into Android. Just note that it would be well worth your time to read up more on nested classes. There's not nearly enough information here about nested classes for what we're going to do. As a general guideline for your access level, make it as restricted as you can. The more restricted you make it, the better, because that means you have less code to test, right? If something's private, I know that if I've got a private variable, I know that no other class can touch that, right? I can limit how many different classes could potentially have access to that variable, which means that if I need to change that variable, rename it, remove it, change its meaning from true means false, false means true, any of those kind of things, or maybe it starts at 1 instead of starting at 0, that means that's more likely to be hidden from the rest of my code base, right? But as soon as I make it accessible, as soon as I even put a getter out there, now other classes may be dependent on that value. So the more private I can make those details, the better. Constants are a great thing. In Java, we already saw one use of the final keyword, which was on a method. So you can declare a method as final, which means it can't be overridden. You can also declare variables as final, which means they can't be changed. So once I set a value to this pi variable as 3.14, I can't change it. It's permanently set that way.
So is it not okay to put constants as we want to, like in a block scope opening, like, it's
Sorry.
not a global, it's like the local variable, is it okay to put constant on local
Yeah.
variable?
So, bit of terminology, okay? They talk about final and constant. As far as I'm concerned, I wouldn't consider a local variable that's marked final as a constant. That makes sense? So let me give a kind of code example here.
Like in JavaScript,
Mhm.
that is right, constant.
Yeah. The const keyword in JavaScript is very close to the final keyword in Java. They behave very similarly, almost identically. So if I have a class that is math, and I've got static, I've got public, go ahead and mark those public when we were talking about it. Public, static, final, double, lots of keywords. Double pi is equal to 3.1. Okay, so this is me declaring a real, it's a constant. It's static final, and it's declared on a class. That's really the only thing I would call a constant. Okay. The other ones are still what I would consider a variable. So let's say I want to say I've got a public method here, and it takes in, say this is multiply, I think what the best way to go about this is. Well, let's just start with a simple case. So if I say int a, int b, then I could say simply, hey, return a times b. Okay, I could do something very simple like that. Okay, we've got a constant, not really connected. If I were to say final product is equal to a times b, return product. This won't really have changed the code at all between what I have there previously and that. But what I'm doing when I declare a variable like this, final, I'm saying I can't change the value of product any time after that. So as soon as I've declared it as final, I can't change it to a different value in the method. But it's still a variable because it depends on the values of A and B, right? If I call this method again, if I call it first with 1 and 2, well, product's going to be 2. If I call it with 2 and 3, it's going to be 6, right? So the value of the product does actually change. I just can't change it in that method after I've set it.
So if that was a constant, it would throw an error, right? Because you can't do a times b.
Right. This isn't really a constant.
Right.
Right. It is const, like if I put the word const here in JavaScript, it has that same syntax. It actually does mean the same thing. But it doesn't, it's not constant in that overarching sense of it's constant, it will have that value for all eternity. Does that make sense?
So,
It has that value as well for that function call.
So when you add, so when you add static, does it make it like constant?
So this does not make it constant. Static just says there's only one copy of it in memory, right? So if I've left off the word static, then for every instance of pi, of math, there would be a place in memory to store pi. Every math object would have the same value, but there would be, if I've got 10 objects, I would have 10 copies of that floating around in memory. So this really only saves memory. It means there's one place in memory it's stored instead of 20 places in memory it's stored.
So what's the difference between just marking that constant, the pi, instead of being final?
What do you mean?
Like, why couldn't you just put constant there?
There's no const keyword.
Oh. Okay.
There is no const keyword in Java. There is static and there's final. There is no const keyword. Yeah, they got rid of the const keyword because it created a lot of confusion in C++.
So is there anything that like makes it constant, like can't be changed at all?
This cannot be changed at all. This pi here, because it declared it static final, can never be changed.
So that does make it like constant.
Yeah. So class level constants like this are actually constant.
Okay.
But things that you mark final within a method just means that you can't change it later in that method call. Okay. So those kind of things happen. I would strongly advise you to overuse the word final. Okay. It's a good thing. It's a good habit to be into. It's a good thing that as many variables as you can, declare them final. I even would go so far to say your member variables, if you can, make them final. Because it does solve a lot of different problems or avoids a lot of different problems. So let's say my default is I make every variable I can, I make it final. Well, that means that I'm less likely to screw up and change a variable that's not supposed to be changed. Because most of your variables you should define once, that's their value, they'll never change. And once you get in the habit of putting final everywhere, you'll really find that most of your methods have maybe 3 or 5 variables that are not const. They're not final. And many of them will have none. Now, that being said, things like loop variables, if I have for int I, yada yada, well, obviously that can't be final because it has to change every iteration. So your loop intervals are the big ones that you can't. Anytime you're dealing with loops, those are usually the ones that you can't make final, but most other things you can make final.
Well, like in C#, if you did like constant product and then equals A times B, that wouldn't work, right?
Huh? If I
say
say
that constant in C#,
no, that
it
would
would
still
still
work.
work.
It still work.
Oh.
Yeah, it still work because again, it's local to here. It's constant within this particular function call.
Because I did like environment dot get environment dot get environment variable or something like that, and it wouldn't compile.
Okay.
Because it's constant.
You might have to use the word read only in C# instead of const.
Okay.
Because there is a distinction between, in C# there's the word read only and there's the word const, and they're similar but different.
Okay.
So it might be that you had to use the word read only there.
Okay.
So that's what that means. So we have a few different meanings of final. One is you can apply it to a method, and that means that the method cannot be overridden. You can apply it to a variable, and that means that variable can't be changed once it's been given a value. You can also apply final to a class. Any guesses as to what that might do?
It keeps other classes from inheriting from it.
Correct, yeah. So if I make a final class, I can't inherit from that class. So final has a different meaning depending on the context. And that's what you need to understand. But it's definitely one of those words that you should use as much as you can, because it does make for more readable code. You can also, in your parameters that you take into a method, you can mark those parameters as final, which means I can't assign a new value to them in the middle of the method. So if I said final string A, I'm not allowed to say A equals something else. And this is a good practice to be in for most of your input parameters in marking file. That's a pretty good practice. Especially for one of the things we talked about yesterday, we talked about taking an integer array in, right? Probably if you're taking an array, you want to go ahead and mark that file and say, hey, I'm not going to assign a new array there. Now that being said, marking an object that I'm taking in, like let's say this is an array. Let me write that up real quick because that's important to see. There's two things there's one thing that works and there's one thing that doesn't. So if I have a function foo and I say final int array at A, let's say I have two different lines of code here. A is equal to new int array 3, or I have A0 is equal to 7. So remember I've marked this word, this variable, this parameter here, this array is final, okay? This is disallowed. The first one is invalid. I will get a compiler for that. Compiler error for doing that. Because it's final, I can't assign it a new value. However, this down here, that is valid and allowed. This is valid, that's not. Which means that it's not really making it constant. Okay, another reason why I would only say static final, those things are constants, the other uses of final are not constants. Does that make sense? I'm not really enforcing that the array can't be changed. I'm just saying I can't reassign a new value to that array, but I can still modify that data.
Can you mark like a specific index of an integer array as final?
No. So anytime I pass an array to a function, that function could potentially change it. And there's no way for me to prevent it other than making a copy of the array.
You say that's used a lot,
What do you mean, what's used a lot?
the constant mention parameters.
Yeah, that would be a good thing to be kind of in a practice to mark them as final. It's usually a good thing to kind of be safe, but that's kind of a gotcha, in the sense that it's helpful, but it's only so, there's a limit to how helpful it is because it doesn't prevent things like this. Similar thing if I had an object in here, I can call a setter even though I can't reassign a different value. So I can still call setters, or I can still call access. I can still access or change values here, but I can't put another object there. in recent version of Java, there's also something called a compile time versus a runtime constant. As far as things go, as far as writing code and getting valid code, there really is very little difference between compile time and runtime constants. The difference between the two is in a performance difference. Okay, this is why we care. So if I look at, for instance, this one, static double C is equal to 3E8. Well, that value, I've determined that C is always 3 times 10 to the 8. That value will never change. So when Java actually compiles this file, any class, whether it be this class or some other class that's using C, it will actually potentially replace that with this constant. Instead of doing a memory access to that variable, it will just sub in that value. Does that make sense? So it will actually replace any instance of C with this, with 3E8, which makes things a little bit faster. Okay. If I look at this one, this is a runtime constant because I've left off the word static. Because I've left it off the word static, it has multiple places in memory it can be, which ends up resulting in meaning that it can't do the optimization if it's not for static. What do you mean?
The first one.
Yeah. If you're declaring statics, if you're declaring constants, they should be static final or final static. The order doesn't matter. But static final is kind of the most commonly the way. You can kind of see in here static int. This is, to some sense, it's a constant, but because it comes from a random number, that constant is different every time you run the program, right? So it's not the same kind of constant, if that makes sense. It still changes every time you run the program. So, yeah, we want to mark things final wherever we can. That's the gist of that. So interfaces, let's see where we're at. We're on 17. Okay, so interfaces are sort of like abstract classes. Remember, an abstract class is something that you can't create an instance of, right? Because it's not finished, if that makes sense. It's not fully implemented. And typically an abstract class would have methods that are abstract. They're not fully implemented. So an interface only contains, basically, with some additions with recent versions of Java, pretty much only contains abstract methods. Okay, that's historically all that an interface was. It's a collection of abstract methods that you have to define in order to implement the interface. Okay, so the way I declare an interface is kind of like the way I declare a class. Just like I would say class, my class, I say interface, my interface. So the interface keyword is what I'm going to use here. I also want to make sure I mark those public. So I'm going to say public interface, my interface. Okay, so when I'm creating methods in those interfaces, I'm going to declare them like so. Int my method parameters. You can see there's a semicolon at the end. So semicolon means I'm not defining what the body of this method is. I'm going to leave that up to whoever implements my interface to define the body of the method. Okay, so if they don't declare it, there's a compile time error. You have to define all of these abstract methods. Any interface implement, when you implement this method, this has to be public. When you implement the my interface method, you're going to have to make my method public. So we leave off the access modifier because it has to be public. Okay, you don't have an option. So we just leave off the access modifier and it will be public. You can also, with newer versions of Java, you can now add constants to your interface. So if I say int c is 10, this is now implicitly static point. That's a constant. So if I wanted to get this constant, it would be my interface dot c.
Do you have to assign it?
Yes, it has to have a value. Yeah, because it's a constant. Right? If it didn't have value, if I just said int c, well, what would it be defaulted to? It would have to default to 0, but then what's the value of having it?
So your other class is implemented?
But this, remember, it's set. It's only occurred once. There's not a copy of this for all the implemented classes. Make sense? There's only one copy of C. So if you declare a variable like this, those are constants. Int c is 10 is a constant. May look like a member variable, but it is a constant. Another thing that's in here with newer versions, you can also create subtypes in here. So I can have classes, I can have interfaces, I can have menus. So these are now part of that interface. So if I want to refer to this, this is called a new. This would be myInterface.new. Would be the name of that enumeration. Or this would be myInterface.interface, myInterface.class. When I refer to it, I need to both include the name of the interface as well as that subname. Okay. That can be helpful as in if you get into much more weird interfaces where maybe you need to provide some default implementation, or there's some menus, there's some values that need to kind of go with there that need to be grouped together. This is something don't worry too much about because I highly doubt we will do any of this semester. It is there, and we will do quite a bit with interfaces, but this is one thing that we probably won't do as far as everything we do in Android. So for example, if we look at a common interface that exists in Java is called the comparable interface. And that provides a way to compare two objects. Okay. Here they have it as a compare method. The actual one is the actual comparable class has a compare to method. So it's an interface called comparable. It's got a method called compare, takes an object, returns an int. Okay, so any class that implements comparable would need to implement this method with that signature. So we need to go public. Okay. So when we implement an interface, we need to use implements keyword. As I kind of mentioned earlier, we use the extends keyword for classes, and we use the implements keyword for interfaces. Typically, if we have both, we're going to do extends and then implements afterwards. So extends typically comes first, although it's not necessarily required. So I'd say implements comparable. Here I've got circle, implements comparable, public and R. Well, this is not going to compile because I haven't implemented comparable. So if I want to be able to implement that interface, I need to write an implementation of that compare method. So it might look something like this. I say public int compare, takes an object, remember it means to be public, and then what I'm doing is I'm subtracting the two radiuses. So what that means is if my radius is bigger, you're getting a positive number. If their radius is bigger, you're going to get a negative number. If they're the same, you're going to get 0. That makes sense? You'll also notice that we have an explicit cast here, circle O. Why do I need to do an explicit cast there? Because it's an object, it's not a circle. Does an object have a variable called R? No, it doesn't. So in order to get to that R, this radius, it has to also be a circle. And really, I only want to compare circles with each other. I don't want to compare rectangles with circles. It just doesn't work. Right? I want to only compare circles with circles. So that's where I'm assuming whatever I'm comparing it to is probably also a circle. Now, this is one of those reasons why having rectangle subclass triangle is probably a bad idea, because then you end up with comparisons like this, and in the triangle, I maybe write my compare to, and assume, well, I'm comparing triangles with triangles, or I'm comparing rectangles with rectangles. Well, if I kind of write it the same way for triangle and rectangle, what I'm going to find is one gives me one answer. If I call it rectangle dot compare to triangle, I'm going to get one answer. If I can say triangle compared to rectangle, I get another answer. That's not good. Anytime you write the compare to method, you want it to be the same both ways. If I compare A to B, it should be the same as B compared to A. So if I want to use that, if I want to use that interface we just declared, I can use that way, and then anything that implements the comparable method will be able to work with this. Again, the reason that exists is so that we can have a bunch of different, we can have, even though we have that limit of only one parent class, we can implement as many interfaces as we want, so that often gets us around those things where we need to implement other things, like comparable. So interfaces are often used for things like where I need to add additional functionality. I need to say, this class can also do this, in addition to what it, or it also function in this way. Exposed. You'll see some of this if you ever start working with unit testing and mocking. Oftentimes you'll see things like this where we're saying, here's my interface, and here's the method I exposed. This is the method you can see, but I also have some kind of behavior that's hidden. Now, typically this would be marked private as well. Down here. But that way we can have like, hey, this is what it should look like from the external side. Pretend like this hidden method isn't there. We can, as of later versions of Java, we can now add static helper methods to our interfaces. Well, sorry, to our classes here. So there's a class here that's a subclass. So we got helper class that's inside of my interface that's nested, and it's got the static helper method. This is used for things like, well, for instance, the collection interface has a lot of methods, right? Or the list interface has a lot of methods. If you were trying to implement your own list or your own collection, you would be duplicating a lot of code, because a lot of those methods, there's a standard way of implementing them that works for most. So in order to simplify that, what was added is both this helper, which you can use. These helpers make it quicker to implement an interface that's got a lot of methods. Or you can also have default implementations. So if you have something like this, default void, default method, this is a default implementation of default method. So if I say I have my class that implements my interface, which I have here, implements my interface, I don't actually have to define default method now. I can override it and create my own special implementation, but I don't have to. So if I don't give my own special implementation, it will have this kind. So that can save you from having to duplicate a lot of code when you're implementing interfaces, because you can put standard, like, here's the normal way you would implement this method. So if you don't have anything special you're doing with this class, just use that implementation.
So using that, can you like functionally like trick an interface into acting like a class that you're extending?
Sort of, yes. Yes. This, with all these new things that we've added to interfaces in the last few versions of Java, yes, interfaces are a lot closer to classes. They're not all the way the same, but there's a lot more that's allowed, which is nice. These are things that unless you start building your own versions of collections, you probably won't see too much of. But they are very handy, especially when you get into the world of needing to build your own data structures. These things are really, really helpful then. So without having to even declare default method, it already has that implementation. Static method. So interfaces can also now have static methods. That was another thing that you could do. Back, I think, Java 5 or so, when I started playing with Java, really the only thing we could do was this. That was the only thing that could go in an interface, was abstract methods. So all the other stuff that's been added in here is really useful, and I wished, 10 years ago that I had these things, but they're here now. So there's a lot more things you can put into interfaces. They can do a lot more things than they used to. Abstract, we kind of touched on that a little bit. Abstract classes means that you can't say new. I can't create a new instance of anything that's abstract. And it means that I can also put in methods here which are abstract and say, I won't define the implementation of this here, we'll define it in the subclasses. So for instance, here I have shape. Well, all shapes should be able to have some way to get their area, but every shape has a different way of calculating area. So we'll let them define it. So we'll have shape, and then we'll have triangle and rectangle both be a subclass of shape, and they define their own way of calculating area. Yeah. So rectangle is x times y versus triangle would be x times y divided by 2. Kind of thing. So I've got my shape with the constructor. Yeah. Okay. If you have the option between making an abstract class or an interface, it's not clear which you should do, make an interface. It's generally better to make an interface and not have another abstract class. The reason being, going back to that rule of you can only be a subclass of one thing. So remember, there's only one class you can inherit from. So your abstract classes, if you've got a bunch of those, then you get yourself into a place where I need to be a subclass of 3 abstract classes, and I can't do that. But I can be a subclass. I can implement 3 different interfaces. So definitely prefer interfaces over classes anytime you have the option, over abstract classes anytime you have the option. Especially since, depending on what framework you're using, you are very likely be forced into using a specific abstract class already by other things from the GUI framework and such. Enumerations do exist as well in Java. It is important to note that they are very different. Okay, so in C#, enums are always primitive types. They're always a subclass, they're always a specialization of a primitive type. in Java, enum values are objects, and they are always objects, which means that enum values can have methods and they can have variables, which are two very useful things, but you also things you have to be careful with. It also means that enums work quite different in Java than they do in C#. Okay.
If you give an enum a method, would you want to always keep that private because that method should only refer to what you run on a method?
So an enum value, if you add a method, it should probably be public actually, but you should only have getters. You should never, ever, 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 ever have a setter on an enum object, because effectively they need to be constant or immutable. Okay, so getters are perfectly fine. Getters are great, and that's why that actually exists as them being objects, is because now you can add getters to them. That's actually immensely valuable. But you should never add a setter to your enum. You should never have a manipulator of any sort.
So you set it to like a string instead of just like being a number? Like say stop is like...
Well, I can do even more than that, right? So I can say, if I say enum, let's call it thing, or maybe we say speed. I might have things in here, for instance, I might have a double, which is the speed in, say, meters per second. So I might have a speed there that's a value, maybe call it V, and I might mark these things private, specifically private final. So a little bit more here than maybe we have time to finish up, but we'll come back to that tomorrow, because enums are very different again, but that's something we really need to take a little bit more time tomorrow to dive into. But there's a lot of value in them being objects. Yeah. So 19, we're pretty good. So we might be able to finish that up tomorrow.